5 partial differential equation. Very well that here partial derivative. Example you can comma y dependent here. Dependent on comma y. Standard notation. I will write the standard notation. P.
Your voice is not audible, sir.
Now? Now it is audible?
Now it is okay, sir.
Okay. Place of dou z by dou y, you can write.
Sir, this is not audible, sir.
Huh?
Question is
Voice is not audible. I think sound is okay. Is in mic. Mic. Huh? Campus in campus. Only for her, other people also not audible my voice.
సార్ ఇప్పుడు ఓకే సార్, ఇంతకుముందు వినిపించలేదు.
Okay. Now okay na?
Now okay, sir.
Okay. So here in place of dou z by dou x you can write P. In place of dou z by dou y you can write Q. In place of dou square z by dou x square there means you can write on that place R dou square z by dou x dou y is there means you can write on that place S comma dou square z by dou y square is there means on that place you can write T. Okay, these are the standard notations. Depending upon the situation, if anywhere depending upon the situation, if dou z by dou x is there means you will use P, and dou z by dou y is there means you can write Q. Dou square z by dou x square is there means you can write R, and dou square z by dou x dou y is there means you can write S. Dou square z by dou y square is there means you can write T. Okay. So in this first topic is formation of PDE. Okay, formation of partial differentiation, partial differential equations. So this is the first topic in Unit 5. This first question is derive PDE by eliminating constants from 2z by x square by a square plus y square by b square. In this 1 by a square and 1 by b square are the constants. So we need to eliminate these constants. So by doing partial differential equation, by doing partial differentiation, in that process automatically you will get the required partial differential equation. Okay. So generally in differential equation, suppose two parameters, two constants are there means we will derive up to order 2. But in case of PDE, it's not like that. So there is no restriction that you need to do up to second order, up to first order, based on the constant. It's not like that. It's our wish. You can derive up to the first order or second order. But in that process, we must need to eliminate these constants. And automatically in that process, you will get the required PDE. When it comes to the operations, that it's our wish. You can do any operation, that is uh, subtraction or addition, division, multiplication, whatever it may be. Given that 2z equal to x square by a square plus y square by b square, equation number 1. Okay. Partially differentiate equation 1 with respect to x. So now partially differentiate equation 1 with respect to x. Then you will get here 2 dou z by dou x equal to 1 by a square is a constant writing outside. So this x square will become 2x plus y square by b square. So whenever we are doing with respect to x, this y square by b square, we need to consider it as a constant. It will become 0. So we know very well that whenever we are partial derivative with respect to x, so except x remaining all, we need to consider it as a constant. We may ask that why you consider here z as a variable, because z is a function in terms of x comma y. So that's why you need to consider it as a variable. So here too, we know very well that in place of dou z by dou x, you can write p. Okay. Then you will get here 2x by a square, 2 will vanish out, and I am going to transfer this x from RHS side to left hand side. Then you will get here p by x equal to 1 by a square. So consider it as equation number 2. Okay. Now partially differentiate equation 1 with respect to y. Then we will get here 2 dou z by dou y. This whenever we are doing with respect to y, this x square by a square, we need to consider as a constant. It will become 0 plus 1 by b square is a constant writing outside. This y square will become 2y. Then you will get here 2. In place of dou z by dou y, you can write q. So here we will get here 2y by b square. 2 will vanish out. So y I am going to transfer from RHS side to left hand side. Then you will get here q by y equal to 1 by b square. Okay. So now we got 1 by a square and 1 by b square. So if you substitute this 1 by a square and 1 by b square in equation 1, so the constant a and b will eliminate, and the resultant will be our required partial differential equation. So substitute. In 1, okay, then you will get 1 by a square, x square writing outside. In place of 1 by a square, you can write p by x plus y square right outside. In place of 1 by b square, you can write q by y. Q by y, okay. So here x square is there, here x is there, 1x will go. Here y square is there, y is there, 1y will go. Then here we will get that 2z equal to px plus qy. Okay. So so it is our required PDE. Okay. So is it clear for you people? If you confirm means I will proceed further. That means I will go for next problem. Can anyone confirm? Okay. So next I will go for next problem. That next problem is z equal to f of 2x plus 3y. Okay, now. So how they will ask this question means if z equal to f of x comma y, find PDE by eliminating arbitrary function. Arbitrary function f, that this is the arbitrary function f. So we need to eliminate that function. So by applying the partial differentiation, in that process automatically we'll get the required partial differential equation. Given that z equal to f of 2x plus 3y, it is equation number 1. So I am going to differentiate with respect to x one time. Then we'll get here dou z by dou x f dash of 2x plus 3y. And here again we need to do this internal function like chain rule. This 2x will become 2. This 3y will become 0. 2x plus 0, 2. In place of dou z by dou x, you can write p. 2 f dash of 2x plus 3y. May consider it as equation number 2. Okay. Partially differentiate with respect to x. Partial differentiate equation 1 with respect to x already done na y with respect to y. Then you will get here dou z by dou y. Then you will get here f dash of 2x plus 3y. This 2x will become 0. This 3y will become 3. 0 plus 3 is 3. Okay. So in place of dou z by dou y, you can write q. Okay. Then you will get here 3 f dash of 2x plus 3y, and it is equation number 3. Okay. Now, as I said earlier, it's our wish you can do either addition or subtraction, either division. The possible calculation we need to do. But the thing is, we need to eliminate this arbitrary function f. Here, if you see equation 2 and 3, if you divide these two, f dash will vanish out, and that means that arbitrary function will eliminate, and you can get the record PD. So that the same thing I'm going to do. From 2 by 3. Then see here, P equal to f dash of 2x plus 3y by q by 3 f dash of క్లాస్లో ఉన్నాయా నేను ఒక హాఫ్ అన్ అవర్తో చేస్తాను ఒక హాఫ్ అన్ అవర్తో చేస్తాను ఓకే okay, everything is fine. Now f dash will go, then you will get here p by q equal to 2 by 3, then you will get here 3p equal to 2q, 3p minus 2q equal to 0. So therefore, it is the record PD. Okay. It is clear? Is it clear for you? To confirm means I will proceed further. That means I will go for next problem. Can anyone confirm? Okay. If you want to ask like any queries means you can can put those queries in chat box also. Okay. Next one is third one. If z equal to f of x plus at plus p of x minus at, find PDE by eliminating arbitrary functions f comma g. So here f and g are the arbitrary functions. So we need to eliminate these to f and g. So by applying the partial differentiation. So in that process, you will get the required PDE. Given that z equal to f of x plus at plus p of x minus at. So you can want to give it as equation number 1. So partially differentiate with respect to x, then you will get here dou z by dou x f dash of x plus at plus g dash of x minus at. Even if you derive this internal function also, that will become 1. Okay, x will become 1, at will become 0. So we are doing with respect to x. That's why. Again, partially differentiate equation 1 with respect to x. Okay, then you will get here dou square z by dou x square. Then we will get again f double dash of x plus at plus d double dash of x minus at. So here, why I'm doing this 2 times derivation with respect to x only means, if you do next time with respect to t 2 times, in that equation, f double dash of x plus at plus g double dash of x minus at will come. So in that place, directly we can replace dou square z by dou x square. Okay, this is equation number 2. Partially differentiate equation 1 with respect to t. Okay, na? Then we'll get here dou z by dou t into a will come. Okay, with respect to t we are doing now, this x will become 0, this at t will become 1, and this a into 1 is a plus g dash of x minus a into minus a, again with respect to t, again partial differentiation with respect to t. Okay, na? So then you will get rho square z by rho t square f double dash of x plus at a square. Why a square means here 1a will become already 1a is there. So a into a square plus g double dash of x minus at. Here already minus a is there. In this term more minus a will come. Minus a into minus a plus a square. Okay. So here a square you can take outside. Rho square z by rho t square. A square is writing outside. Have double dash of x plus at plus g double dash of x minus at. From 2 in place of f double dash of x plus at plus g double dash of x minus at, you can write here dou square z by dou x square you can write. Okay. So from 2 a square that's it. So it is required PD. It is the therefore it is the required PD. Okay. Is it clear for you? If you confirm means I will go for next problem. This problem is clear for you. Okay. So then I will go for next problem. Fourth one. Problem is if z equal to x plus y into phi of x square minus y square. This is phi z equal to x plus y phi of x square minus y square. X plus y. Find PDE by eliminating function pi. Okay, na? So by doing the suitable calculation through partial differentiation, we need to eliminate the function pi. Okay. Whatever the resultant we will get resultant equation we will get. That is the secured PDE. Given that z equal to x plus y into pi of x square minus y square, it is a equation number 1. So that one z by x plus y equal to pi of x square minus y square. Yeah, that means if anywhere in place of, like if anywhere pi is there means on that place we can write z by x plus y. So in upcoming equations. Now partially differentiate equation 1 with respect to x. Okay, then we will get here rho z by dou x. Here uv formula will come. Okay, we are going to use the uv, that is uv dash plus u dash. So here we are going to use the uv. So here we will get that first x plus y, that means uv dash, that here we will get that pi dash x square minus y square. Okay, so this internal function we need to do now with respect to x. Whenever we are doing this, x square will become 2x, y square will become 0. So here we will get here 2x uv dash plus vu dash. V is this pi function, pi x square minus y square, and this x plus y will become 1. Okay, we are doing with respect to x. This x will become 1 plus this y will become 0. So 1 plus 0 is 1. So into 1. That's it. Place of dou z by dou x, you can write p minus, here pi function I am going to transfer from this RHS side to left hand side. Here you will get that pi of x square minus y square equal to, here you will get 2x into x plus y pi dash of square minus y square. Okay. So here I said earlier also. So wherever pi function is there on that place, you can write z by x plus y by using equation 1. So here pi is there. So in place of pi, you can write z by x plus y. So I'm going to write that. P minus my voice is audible for you people now. Actually, due to network issue, so I was disconnected from the meeting. It was automatically happen. Now is my voice is audible for you people? Okay, so we'll solve this one remaining problem. Here this one. In place of pi function, we can write z by x plus y 2x into x plus y pi dash of x square minus y square. Consider it as equation number 2. Okay. Now with respect to x is over. Now we will do with respect to y. Partially differentiate equation 1 with respect to y. Okay. Then you will get here dou z by dou y. Here for this one we are going to apply uv na. So then you will get here first u x plus y is x plus y only. Then pi dash of x square minus y square. Internal function also we need to do chain rule. This x square will become 0 because we are doing with respect to y partially differentiation. So this minus y square will get minus 2y plus pi of x square minus y square, and this x plus y will become 1. Okay. In place of dou z by dou y, you can write q minus 2y into x plus y pi dash of x square minus y square. In place of pi, you can write z by x plus y from equation 1. Okay. Next, q, I'm transferring z by x plus y from RH side to left hand side. Z by x plus y equal to minus 2y x plus y pi dash of x square minus y square, which is equation number 3. Okay. Now if you divide this 2 and 3, this pi function will go. So remaining is the required. That means whatever the resultant equation you will get, that is the required PD. P minus z by x plus y by q minus z by x plus y equal to 2x into x plus y pi dash of x square minus y square. Next remaining minus 2y x plus y pi dash of x square minus y square. Okay. So this x plus y will vanish out. Pi dash function will vanish out. Next this 2 also will vanish out. Okay. This one here p by 1. Here it is q by 1. So after doing cross multiplication, what we will get here? P into x plus y minus z by x plus y by q into x plus y minus z by x plus y equal to minus x by y. Okay, so that is x plus y will vanish out. Remaining term we will get here p into x plus y minus z by q into x plus y minus z equal to minus x by y. So if you want, you can stop here up to here also. Otherwise, if you simplify also, you will get the result yp plus qx equal to z is qx here. Okay, that means if you cross what it remains here. Okay, that's it. I will stop. Okay, is it clear? This, up to this problem is clear means I will end I will end this meeting. Okay, so you can join next class. I'm ending this meeting.